Force and motion. We are going to look at the different objectives that we are covering in Unit 6. Potential and kinetic energy, balanced and unbalanced forces, calculating average speed, and measure and graphing changes in motion. Potential and kinetic energy. Potential energy is the stored energy in an object or the energy due to an object's position. Potential energy is affected by mass and position, or height. Kinetic energy is the energy of motion. Kinetic energy is affected by mass and speed. The greater the mass and speed, the greater the kinetic energy. Look at the picture. Which letter represents the most potential and kinetic energy? Potential energy is determined by mass and position. So if we are to assume that the roller coaster car would have the same mass during the entire ride on the roller coaster, we would need to look at the position or height of where the car would be during this ride. So we have F, the top of the tallest hill. We have G, which is coming down the first hill. H is when it's getting ready to climb again, and K when it is climbing. The most potential energy would be at point F. Kinetic energy is determined by mass and speed. Again, the mass would be constant throughout the ride, so we would look at speed. And at the positions that it gives us, the car would be going the fastest as it was coming down the tallest hill. So the most kinetic energy would be at point G. Let's look at this picture. If there were two roller coaster cars at point W, so if there were two at point W, one had a mass of 500 kilograms and the other car with a mass of 800 kilograms. Which would have the most potential energy? Potential energy is determined by mass and position. In this problem, the cars are at the same position, so we need to look at the mass. And the car with the most mass would have the most potential energy. So it would be the car that was 800 kilograms. A force is a push or a pull that changes the motion or position of an object. The different forces that we've talked about is friction, is the action of one surface or object rubbing against another. Inertia is the tendency of an object at rest to remain at rest, an object in motion to remain in motion. Gravity is the force that attracts objects toward the center of the earth. And the law of conservation of energy states that energy cannot be created or destroyed. Energy is transformed from one form, changed from one form to another. If we're looking at a bike rider that is going to go down two different hills, but they are the same size, but looking at them, one is covered in ice and the other is covered in sand, what will happen and why? The hill covered in sand will take longer for the bike rider to get to the bottom. When he's going over the ice, he will come down the hill very quickly. This is due to the substance that is covering the hill and the friction between the bike tires and that substance. If you've ever walked on a beach or in sand, your feet tend to stick in it as you walk. Which is the same thing if you've ever tried to ride a bike on sand. It's very difficult and you do not go very fast. If you've ever walked on ice or slipped on ice or ice skated, you know that ice is very slick and you tend to go very quickly. Calculating net forces. To or more forces combined together can make a total force or a net force. Forces can act in the same direction or opposing directions or different directions. Let's look at force in the same direction. Two little ants are trying to push a picnic basket back to their anthill. One ant pushes with a force of 10 newtons, and the other ant pushes with a force of 12 newtons. What is the total net force? Since they are going in the same direction, we will be adding the net forces together. So we will take 10 newtons plus 12 newtons to give us 22 newtons of net force. Let's look at force in opposite direction. A group of kids are playing tug of war. One side is pulling with a force of 15 newtons, while the other side is pulling with a force of 8 newtons. What will the total net force be? Since they are in opposite directions, we will take the most amount of force and subtract the lower amount of force, and that will give us 7 newtons. And then we always include the direction to the right. So we know that the net force is 7 newtons to the right. Let's think about the tug of war game again. What would happen if both groups were pulling in opposite directions with the same amount of force? So if both were pulling in opposite directions at 15 newtons. Again, if they're in opposite directions, we have to subtract, and that would give us 0 newtons. Anytime our net force is 0, that means that there is no movement. Neither one is pulling the other one in any direction, so it's staying right where it is. There is no motion. Calculating average speed. Average speed is the distance that is traveled in a certain amount of time. Speed equals distance divided by time. So if we are going 5,000 meters to the store, and it takes us 500 seconds to get there, we need to figure out what our average speed is. So we would take 5,000 and divide that by the time, which was 500 seconds. And we would get 10 meters per second. On the way home, you get stuck in traffic, and it takes you 1,000 seconds. What is your new average speed? So you'd still do distance divided by time. So our distance does not change, but we'd have to divide that by 1,000 seconds. And we would get 5 meters per second. So if it took us 10 meters per second, that means we're traveling 10 meters every second to get to the store. But on the way home, we are only going 5 meters per second. So we know that we had a higher average speed on our way to the store than on the way home. Graphing motion. When we're graphing motion, our distance think about dry mix. Distance is on the y-axis, which means it's our dependent variable. And then we have time, which is on the x-axis, which is our independent variable. When we see a diagonal line, that tells us that, first of all, our distance is increasing, and so is our time. So they are driving away from point A, but they're driving at a constant speed because it's a diagonal line. Now when we get to here, we notice that time is still going, but the distance is not. When we see the line go horizontal like that, it lets us know that the object has stopped moving. And then if our diagonal line goes back down, we know that they're going back to the place they started. They're still going in time, and they're still moving. However, they're moving back to the original place that they started. Let's look at a distance time chart. So in distance in meters, 10, 20, 30, 40. Time in seconds, 1, 2, 3, 4. So they correspond. So for every 10 meters, it took them 1 second. So here's the graph that goes with this. And one way to do this when we have a chart is to plot it out. So 10 meters, 1 second. 20 meters, 2 seconds. 20 meters, 2 seconds. 30 meters, 3 seconds. And then 40 meters and 4 seconds. And then we could draw the line through our points. So we can see they had a constant speed because every second they went 10 meters. So this is a distance time graph. And they were going at a constant speed. Now, if it were to stop, we would see the straight line. And then once they start moving again, we would see it continue to go up if they were moving away from their original starting point. When we want to calculate the average speed looking at a graph, we would have to look at the complete distance and the complete time, and then divide to find our average speed.